list. In this module, you will learn about stack and queue, performing insertion and deletion operations on stacks and queues, infix and postfix expressions, converting an infix to postfix, evaluation of postfix expression. Let us begin the session by understanding what is a stack. A stack is a data structure whose elements are accessed according to the last in, first out (LIFO) principle. Reason being, in a stack, you can insert and delete the elements at one end only, that is, at the top of the stack. Real-life examples of stacks could be a pile of books, a stack of coins or paper glasses placed one above another, and so on. Let us understand the concept of stack with the help of an example. Consider a pile of coins kept one above the other. If you wish to add one more coin, you can add it only on the top. If you want to remove any coin from the stack, you need to remove the coin from the top of the stack. That means the coin that is kept last in the stack has to be removed to first. You can perform two basic operations on the stack. They are push and pop. Push is used to add or insert new element onto the stack, whereas pop is used to remove or delete an element from the stack. Let us look at the push operation. Push operation is adding new element to the stack list. If the stack is empty, the value of top is 1. An empty stack is initialized with an invalid subscript. Whenever you perform push operation, the top value is incremented by 1, and then the new value is inserted on the top of the list till the time the value of top is less than or equal to the size of the stack. Have a look at the algorithm that explains the logic to program the push operation for a stack. Let us now look at the pop operation. Pop operation is removing existing elements from the stack list. Before performing pop operation, you need to check if the stack is empty. Stack is empty if the value of top is -1. Such a situation is known as underflow. You cannot perform pop operation on empty stack. If the stack is not empty and an element is deleted from the list, the top is decremented by 1. Here is an algorithm for pop operation. Next, let us learn about traversal in a stack. Traversal means moving through the elements of the stack. Look at the algorithm to display all the elements of the stack. As you have studied earlier, in Python, pop and append functions are used for popping and adding elements onto the stack respectively. Hence, you need not write the code to add and remove elements in the stack. Here is a program that performs the push and pop operation on the stack through append and pop function. Output of the program looks like this. On screen is the implementation of the same program using classes. Output of this program looks like this. Let us now move on to the next concept, expression. An expression is a combination of variables, constants, and operators. Expressions can be written in three different notations, namely infix, postfix, or prefix notations. Infix expression. Here, the operator is placed between the operands. Examples are shown on the screen. Postfix expression. Here, the operator is placed after the operands. Examples are shown on the screen. Prefix expression. Here, the operator is placed before the operands. Examples are shown on the screen. Here is an algorithm that illustrates the logic to convert an infix expression to an equivalent postfix expression. Look at the first example. The resultant postfix expression is shown on the screen. Look at the second example. The resultant postfix expression is shown on the screen. Here is an algorithm that evaluates a postfix expression. Look at the first example. The answer is -11. Look at the second example. The answer is true. Let us now look at another most common data structure found in computer algorithms, that is, queue. We are all familiar with the concept of queue in our daily life. We stand in the queue at fee counter, at the bank, at the billing counter, etc. A queue is a container of elements which are inserted and removed according to the first in, first out, FIFO principle. Let us understand the concept of the queue with the help of a real-life scenario. Consider a queue at the ticket counter of a theater. The person who stands in the queue will get his movie tickets first, and the person who stands at the second position will receive the tickets next. Similarly, those who come late will join the queue at the end. In simple words, it is called first in, first out. In technical terms, a queue is a linear list to keep an ordered collection of elements or objects. The basic operations that is performed on the queue are addition of elements and removal of elements. Adding an element is known as insert operation or enqueuing. It is done using rare terminal position, that is, tail end. Removing an element is known as delete operation or dequeuing. It is done using front terminal position, that is, head of the list. Since both these operations in the queue are performed from different ends, we need to maintain both the access points. These access points are known as front and rear. Front is first element of the queue and rear is last element. As queue uses FIFO, front is used for delete operation, whereas rear is used for insert operation. Let us look at some applications of queue in computers. In a single processor, multitasking computer, job or jobs waiting to be processed form a queue. Same happens when you share a printer with many computers. Queue is used for ordering the files while compiling a HLL code and while using Download Manager for multiple files. Job scheduling in multi-user OS is also done through queue. You can perform various operations on a queue, such as creating a queue, having a data structure to store linear list with ordering of elements, inserting an element using rare, where rare is incremented to hold the new value in queue, deleting an element using front, where front is also incremented to access the next element. Let's understand this with the help of an example. Consider a list data type to implement the queue. Initially, queue is empty. Hence, front and rare will not be able to access any element. This situation is represented by assigning -1 to both rare and front as initial value. F front equal to -1R rare equal to -1. Once you create a queue, you can perform various operations on it. Here is the list of operations with its effect on queue. Insert 6. F equal to F plus 1. R equal to R plus 1, as this is the first element of the queue. Here are few delete operations. In the last scenario, since the queue is empty, you need to handle this exception. You cannot delete from an empty queue, and this situation is known as underflow situation. Similarly, when you work with fixed size list, insertion in a full list leads to overflow situation. In Python, as you don't have fixed size list, you need not bother about overflow situation. Here are algorithms that show the formal steps for insert and delete operations. Although principal operations in queue are insert and delete, however, you need to know the contents of queue at any point of time. To handle such requirement, you need to add traversal operation in your program. Here are the algorithms for the same. Have a look at an algorithm for display, traversal in stack. You have already learned about delete and append functions. Delete function deletes the elements at the front, and append function adds the elements at the rear. Hence, there is no need of writing special function for adding and removing elements in the queue. Likewise, while implementing queue, you do not need front and rear positions. Here is a program that implements queue using list. Here is another program using class. In this module, you have learned a stack is a data structure whose elements are accessed according to the last in, first out LIFO principle. You can perform two basic operations on the stack. They are push and pop. Push is used to add or insert new element onto the stack, whereas pop is used to remove or delete an element from the stack. Push operation is adding new element to the stack list. If the stack is empty, the value of top is 1. Pop operation is removing existing elements from the stack list. Stack is empty, if the value of top is -1, and this situation is known as underflow. An expression is a combination of variables, constants, and operators. Expressions can be written in 3 different notations, namely infix, postfix, or prefix notations. A queue is a container of elements which are inserted and removed according to the first in, first out FIFO principle. Front is first element of the queue and rear is last element. As queue uses FIFO, front is used for delete operation, whereas rear is used for insert operation.